Alright, you guys, section 4.5 starts on page 177, and we're going to jump straight into example 1. This section is when we combine our linear inequalities and we have systems of them, aka we have more than one. And once again, Desmos.com, DESMOS.com is going to be our best friend. You should go to that and go to that graphing calculator right now. All right, example 1A tells us to graph each system of inequalities. So what you see here is you have two inequalities, and we're going to graph them both. So let's go to Desmos. Nope, I'm going to clear out what I got. Here we go. First one is y, if I can find my y, is less than 2x. And it graphs that for us. Y is less than 2x. And our second one is y is greater than -3. Notice there's no x in that, so that means it's just going to be a straight line, horizontal, vertical. And look what happens here, you guys. It will shade it for us, and we can see that there is a section of the graph where the shadings overlap. Well, when we're solving a system of inequalities, our solutions are where those two shadings overlap. It's not just one point where they intersect, but truly all of the points where the shadings overlap. So let's look at that and talk more about it now that we've graphed it. So we've graphed this, and I'm going to move this out of my way, make it really tiny. Amazing. So the blue line is our y is less than 2x. The red line is our y is greater than -3. And here's a little review out to the side. If we have less than, we're going to shade below, and it'll be a dotted line. If we have greater than, we're just going to shade above, and it'll also be a dotted line. And we can see that this whole area right here is where those shadings overlap. So we would call this whole area that I am doodling in purple our solution. Take note, the solutions, and yes, solutions, more than one, the solutions are where the two shades overlap. So any point in this set of all of these shades would be a solution. So you guys go ahead and go to Desmos and graph part B and just see what it looks like. Y is greater than or equal to -2x plus 1, and y is greater than x plus 2. You guys graph that. You can do it. Go to Desmos, graph those two things. All right, let's look at them. We end up with two lines, two shadings. Let's zoom in and look at them. Y is greater than or equal to, pay attention, it has that or equal to, that's that blue line, because it's a solid blue line because it's got this or equal to, and it's greater than, so we're shading above that line. The second line is y is greater than x plus 2. Notice it's not or equal to, so it's a dotted line represented by these dashes, and we shade above that line as well. And we do have our place where they overlap right up here, this top little bit. Any point in that area is our solution set. Any point in that area would be our solution. So let's jump to example 2 and practice writing these system inequalities and finding those solutions. So 2A says what system of inequalities is shown by each graph, and they go ahead and give you our two lines, and so we are going to write the equations of both of these lines, and that is our system of inequalities. Let's start with the red line, and notice it is a solid red line that is shaded above the graph. So if we're solid, we're going to have the or equal to, and if we're shaded above, we are greater. So that is greater than or equal to. We have our y is greater than or equal to. Let's find our slope going rise over run from one point to another on the line from left to right. We go up 1, 2, 3 over 1. So that's going to be a 3 over 1x. And our y-intercept is at 1 plus 1. So that line is y is greater than or equal to 3x plus 1. Let's do the blue line now. Blue line is also a solid line, so we know it's going to be an or equal to, but it is shaded below, so it's going to be a less than or equal to. Let's find our slope. Go up 1 over 1, that's just 1, that'd be 1x. Let's find that y-intercept. Where do we cross that y-axis? It looks like right down here at -1. So that'd be y is less than or equal to x minus 1. These two equations are our system, and their solution is anywhere this overlaps. Look at this area right here where those two shadings overlap. That would be our solution. Sometimes you're asked, like, is this point a solution? So let's practice that. If I said, is -8 2 a solution? Let's find out. Let's go to where x is -8, y is 2. That's up here. Is that part of the overlap? No. So no, it's not a solution. What if we said, is -8 -12 a solution? Where x is -8, y is -12, and that's right down here. That is in the overlap, so yes, it would be. That's how we can practice solutions, is knowing that all of the points in this overlap, if it lies in this overlap, it's a solution. Let's do part B. Part B, we have two lines, red line and a blue line. The red line, let's see, it's shaded above the line and it's dotted. So that's going to be the greater than symbol. We're greater than the line, but we're not equal to it, so we're a dotted line. Let's see if we can find our slope. Here's my y-intercept. Let's find another point on the line. We go from left to right. Here is a perfect intersecting point on that red dotted line. We go down and over. How many do we go down? We go down 1, 2, over 1. So we went down, so that's negative. That's going to be -2x. And let's find that y-intercept. We already found that. That's right here at 0. We're not going to say plus 0. We don't need to write that. So that equation is just y is greater than -2x. Let's do the blue line. Find some points on that blue line. Here. Here's another one. All right, so notice that blue line, we are shaded below it, and it's solid, so that's going to be a less than or equal to when we shade below and are a solid line. Make sure you guys have this information, if I can scroll, written down, because this is the most important information about this section, is you need to know, based on where the shading is and if it's solid or dotted, what inequality it is. So make sure you have that written down so you can constantly look at it. Let's go back. The blue line, y is less than or equal to, let's find our slope. We go up 1 over 2, so that's going to be 1/2 x. And let's find that y-intercept. That y-intercept is down here, and it looks like this graph is counting by 2, you guys. My bad. So this would actually be at -4. Let's go back and make sure we've gotten our y-intercepts correct. This one was 0. Good. These counting by 2 as well? Yes. So that means this isn't actually 1, it's 2. This would be -2. All right, so this isn't +1, it's +2. Y is greater than or equal to 3x plus 2. This then would actually not be -1, it'd be -2. Y is less than or equal to x minus 2. Good example, Miss Meyer, of having to pay attention to the units of the graph. All right, but these would be our two for here, for sure. And let's see, where are those solutions? So our solutions are where the shadings overlap. So that's going to be anything over here in this part of the graph where those two shadings overlap. So let's say, is the point 4, 2 a solution? Let's find out. Let's go where x is 4, y is 2. Up here in this yellow, is that part of the overlap? No. Let's find some more points. What if we said, is 6, -4 a solution? Let's find out. Let's go where x is 6, y is -4. That's point is down here. Is that in the overlap? Yes, it is. So it is part of the solution. And that's one way you can determine solutions. That is section